Okay, taking notes over something new today. Going to look at dot structures. So I've linked this in Schoology, so you guys should be looking at this document here. So this document, all kinds of rules about Lewis dot structures, and I'm going to cover all these, but you're probably not going to memorize these. You're probably going to kind of learn the process and kind of go through the process. And so just throwing out that all of this is there, but I'm going to kind of go through this with an example. So, all right. So we're going to go ahead and go through this with an example. And so what you have to do is you have to take a chemical formula and you have to turn the chemical formula into a shape. And by drawing what we're going to call a Lewis dot structure, you're going to be able to figure out this shape. So there are several steps. So first of all, got to have a formula. So let's go ahead and do the one that's in your notes. And with this formula, one of these elements has to be in the middle. Okay, so you have to have one of the elements in the middle and the rest of the elements attached to it. And that's really important because students a lot of times connect these in all kinds of silly ways, but there should be a center. So think of like a wheel. So you have a middle, and then everything else is going to be connected to the middle, right? And so we need that central atom. And so that's the first thing we got to figure out. So what is the central atom in this situation? Okay, so the central atom is normally listed first. Okay, so it's normally the first element. So in this case, it would be hydrogen, but hydrogen is going to be a problem today. First thing we want to remember is that hydrogen cannot be a central atom. So hydrogen cannot be in the middle because it's too little and it doesn't have enough bonding sites. It cannot be in the middle or what we're going to call the central atom. So it cannot be the central atom. All right, so what happens? I'm going to go ahead and underline the word cannot because it's really important that we understand. Don't put hydrogen in the middle. So in that situation, then what happens is if it can't be hydrogen, then you go to the next element. So it's going to be carbon. So we're going to put carbon in the middle. Carbon loves to be in the middle, likes to be a central atom. So we're going to do hydrogen, carbon, and nitrogen. So you just connect them. So you have the one in the middle. This is our central atom, and you connect everything else to the central atom. Now you could connect it like this. It doesn't matter as long as the carbon is in the middle and the other two things are attached to the carbon. Okay, so that's that main thing, is that everything is attached to the middle atom. Okay, so after you do this, we are going to fill them up with electrons. Fill them up with electrons. So we need to go back to our periodic table, and we need to understand that all of these elements want to be like the noble gases. So noble gases are over here. They're going to be, noble gases are going to be over here on the right side. Okay, so that's where our noble gases are going to be. The noble gases are in column 8A, and that means that they have 8 valence electrons. Okay, so over there in 8A, 8 valence electrons. That's what everybody else wants to be. Everybody else wants to be a noble gas. So, okay, so we need to look at the periodic table and we need to write down a few things. So, have your periodic table out. So, what I was talking about on the other page, and I dumped the periodic table into the Jamboard to help out. So, everybody wants to be like the noble gases. And so the noble gases have 8 valence electrons. So you may say, what the heck's a valence electron? A valence electron is just an electron on the outside of the element. So the valence is on the outside. Why is that important? The electrons on the outside are the ones that do the bonding. So all of these have 8 electrons except for helium. Helium only has 2 valence electrons because it only has 2 electrons, okay? Everybody else, neon, argon, etc., they all have 8 valence electrons. Now, the goal of all of these elements is to have 8 valence electrons. So you want to write down, maybe I should write down what valence looks like. That's a valence, and then E for electrons. And these are the outside electrons. So let's write down how many valence electrons each column has. So column 1 has 1 valence electron. Column 2 has 2. The boron, 3. Then 4 for carbon. 5 for the nitrogen column, 6, 7, and 8. So I'm going to clean that up a little bit. Looks a little bit better this way. There we go. So the valence electrons are the electrons on the outside of the atom. And so they are going to be used for bonding. Okay, so we need to know how many valence electrons things have. And so if we go back to our initial example, after you get the central atom figured out, the next step is to add electrons. Now, every one of these elements wants 8. So 8 is the magic number. Everybody is looking to get 8 electrons, and we call that an octet. So like octagon, oct meaning 8. So octahedral. This is 8. And so everything is looking to get 8. So everybody looks to get 8 except, we'll go back to hydrogen. Hydrogen is happy with 2 because it's little. So we're going to write down right now that hydrogen does not get dots. And that's going to make sense in a minute, but no dots on hydrogen. So what we're going to do is we're going to add a dot. Every dot is an electron, and we add them in pairs. Hydrogen does not get any dots. Okay, so I want you to think of the element as having a box around it, a little imaginary box. Every side of the box should have something on it. So it could have a bond or it could have lone pairs, but every side should have something. So if all 4 sides have something, 1, 2, 3, 4, then you're good. If you've got 5 things or 6 attachments or 7 or 8, then you've gone crazy and you got way too much. So right now you get 4 attachments. You have 4 sides to your box, and every side can have 1 item. So the items can be a bond, that's what the line is, or a pair of dots, but only 4. 1, 2, 3, 4 sides to your box, so 4 attachments. Okay, so let's go over to our little box here. What I would do is I'm going to put dots where there's no attachment. So see, there's nothing here and there's nothing here. So I'm going to put a pair of electrons there and a pair of electrons there. See, now every side of the box, 1, 2, 3, 4, every side has something. So that's the goal, right? So every side of the box has something. And so now we can feel good about our chemical because it is going to be stable now. Why is it stable? Because it now has 8 electrons, which is going to make it happy, right? Now look at this nitrogen over here. He's missing 1, 2, 3 things. He only has something on one side. So we are going to go in and fix that. So here we go. Top, right, and bottom. The first step is to find the central atom, and the second step is to add electrons until you get everybody happy or everybody at 8. So what do you mean by 8? Okay, well, everything counts as 2. So the carbon has 2, 4, 6, 8 electrons. So what a line is it's representing 2 electrons that are connected. Okay, so the carbon is good. Now let's look at the nitrogen. 1, 2, 3, 4. So 4 times 2 is 8. So it's 2, 4, 6, 8. So count by 2s. It's happy. And then the hydrogen is okay with 2 electrons. So it's fine with 2. And so where does it get the 2? Well, look right here. That's 2. Because remember, it's a line represents a dot and another dot that are connected. So when you draw a line, what you're really showing is this right there. Okay, so that is good. We've got this thing. It's nice and stable. We're going to go ahead and rewrite it. But the problem is we don't know how many electrons we're allowed to have. That's going to be based upon how many electrons these elements individually have. And so when I told you about the valence electrons a minute ago, I was talking about how many electrons your entire compound is allowed to have. So if we go over here, we want to check the valence electrons for hydrogen. How many does it have? We want to check carbon, and we want to check nitrogen. So we're just going to go and look at the columns they're in. Okay, so here we go. Here are the elements, and so let's find what we had. We had nitrogen, so it has 5. It's in the column 5. Carbon's right next to it. It's in column 4. And the hydrogen's over here. It's in column 1. So hydrogen gets 1. And I know this because it's in column 1. Carbon gets 4. And nitrogen gets 5. So it's 1, 4, and 5. Okay, so we're going to go write those down. Let's go ahead and zoom in. Okay, so hydrogen is going to get 1 electron. Carbon gets 4, and nitrogen gets 5. So if we add those up, 1 plus 4 plus 5, we're allowed to have 10 electrons. So how many do we have? Well, everything counts as 2. So let's count them. Everything counts as 2. 2, 4, 6, 8, 10, 12, 14. Holy smokes. We've got 14. That is too many. So we have too many. We're only allowed 10, and we have 14. So we're going to have to figure that out. All right, so I'm going to pause this video, and I'm going to start another one because I'm going to run out of time. But what I want you to take away from this is that the first 2 steps are to find a central atom, which we did. Fill all of our electrons up. So all of our elements have 8. So a line counts as 2. 2 dots counts as 2. But we learned that hydrogen doesn't get dots because it's happy with only 2 electrons, and it cannot be in the middle because it is just